Hi guys, so we're getting into complex numbers and I'm not going to have you do this first page, but I want to come over here to 742 and we're going to look at this. And it says Cardano, also known as Cordon, considered to be the greatest mathematician of the Renaissance, ran into this problem. Find two numbers, A and B, whose sum is 10 and whose product is 40. So whose sum is 10. So A plus B equals 10. Whose product is 40. A times B equals 40. Now, it wants me to solve this system of equations. So first things first, I'm going to bring this one down here. And I'm going to solve for, let's see, I'm going to solve for B. So if I do that, I would have B equals 10 minus A. Then I'm going to take this and I'm going to plug it in for this B right here. So I have A, and then I have 10 minus A equals 40. So I have 10A minus A squared equals 40. Move all this to one side. A squared minus 10A. Plus 40 equals 0. Oh, but couldn't I do completing the square? I think I'm going to do that. So I'm actually going to move that 40 to the other side because I really like completing the square. So half of the negative 10 would be negative 5. Negative 5 squared is 25. So I would add that on both sides. So then I would get A minus 5 all squared equals negative 15. Oh, but look at this. When I take the square root, aren't I going to be taking the square root of a negative number? Well, Cordano, he noticed this issue, and so he came up with a new system. And these are called complex numbers. And the complex numbers share many properties with the real numbers, adding and subtracting, multiplying, same kind of stuff. But we're going to look at it right here. So in our system, if we multiply by negative 1, we move it straight across 180 degrees on that number line. If I have 2 and I multiply it by negative 1, I go a full 180 degrees. If I'm at negative 2 and I multiply by negative 1, I go over to 2, that's a whole 180 degrees. The problem is what happens when I only want to go 90-degree rotation. We don't have anything that goes to 90-degree rotation in our real number system. And yes, this does look like the coordinate plane that we normally use, but if you notice, we don't have anything on our axis for our rotating of 90 degrees. We are imagining this. We imagine such numbers existed. Okay? This is going to be called imaginary numbers. So we have an imaginary axis and it's subdivided into units. And we're going to use I for that. So what it's saying down here is if I go 90 degrees, I go to I. If I go from 2 and I go 90 degrees, I get 2I. Oh, it made me a line, sorry. If I go from 3 and I multiply it by I get up to 3I. Okay? So, if we're at I, so right now we're going to be at I, and I go I more, or multiply it by another I, I get I times I. Where did I end up? I ended up at negative 1. So that means I squared is equal to negative 1. Okay, so here we go. I squared, we just talked about, is equal to negative 1. If I take the square root of that, that means I is equal to the square root of negative 1. That is our imaginary number. So let's plug this in. Over here, this is going to be the square root of I, or sorry, the square root of negative 1, or just plain I. This is going to be negative 1. I to the third, okay, so if I go another round, so let me do this one. So I went from here to here and I got I. I multiplied it by another I went here and got negative 1. Then if I multiply it by another I, I'd end up at negative I. Let me give you a hint on that. I squared times I. What's I squared? Negative 1 times I. That's where the negative I came from. Then if I go one more, multiply it by another I, I'd end up back at 1. So this gets me 1. And there's a pattern for this because aren't I just going in a circle? So my pattern for this is going to be I. It's going to be negative 1. It's going to be negative I and then positive 1. It's going to be I. To the fifth, it's going to be I. To the sixth power, it's negative 1. To the seventh power, negative I. To the eighth power, I. Or try that again, 1. It's too late at night. What do you think those will be? I, negative 1, negative I, and 1. Okay, do you notice that all of these down at the bottom are all divisible by 4? So, in order to deal with these, we deal with the remainders. So I take 123 and I divide that by 4. So 4 goes into that 3 times, that'll be 12. Bring down the 3, that's 0, so my remainder is 3. So if my remainder is 3, it's going to be like I to the third power, which is equal to negative I. Then if I look at 57, so 57 divided by 4 goes in 1 time. That goes in 4 times. My remainder is 1. So if I have a remainder of 1, that means that this is to the 1 power. So my answer is just I. So you look at the remainders to figure that out. Okay, so when we're dealing with complex numbers, the real numbers always come first. Then comes the imaginary number, the one that has the I. These two are what are called conjugates. These are conjugates. If you notice, the only difference between them is one has a plus and one has a minus. They are conjugates of each other. All solutions will have a conjugate. Okay, so right here, we're going to write the real part, we're going to write the imaginary part. Fill it in. So when you fill that in, you should get this right here. Okay. right here. We're going to simplify these. So this is 4 times 6. But the most important part is the I. Because this has a negative, it automatically has an I. So 2I radical 6. This next one, 5 plus or minus, we already know it's going to have an I because it's negative right here. Oops, I don't know why I did that. It's negative. Seriously? It's negative. This is the same thing as 25 times 3. So 5I radical 3 over 5. Please do not just start canceling things out. It's 5 over 5 plus or minus 5I radical 3 over 5. This gets me 1. This gets me I radical 3. Okay, and this next one, same thing. I have a 2. I have a plus or minus. Gonna have an I. This is 4 times 5. So the square root of 4 is 2. And we can't take the square root of 5. All over 2. To simplify this, we split it up. Get 1 plus or minus I radical 5. Now, I want you to do D, E, and F. So D, yes, you have this negative that's right here, so yes, you get an I. But you have to make sure that the real comes first and then the imaginary. So real has to go first, then the imaginary. E and F. Okay. This next one, okay, it says find the real values for X and Y and each of the following, and this looks weird, I know. Look at this, guys. It says this equals this. Isn't that what it says right there? And then it says this equals this right there. So you're just setting things equal to each other and solving. So I take 3x and I set it equal to 15. Those are the reals. Then I take the imaginaries and I set them equal to each other. And I solve. I'm going to solve this one first just so that I don't have to switch back with the color. There we go. And then this one would be 5. And that's all you do. So let's do the next one. So I take these and I set them next to each other, or set them equal to each other. And I solve. Then I take the imaginaries and I set them equal to each other. Oop, I forgot the negative. Okay, I want you to do C and D, and I will give you a hint for C. This part, and this part, this part, and this part. Okay, do C and D. Okay, so C, you should have done this. And D, you should have done this. Okay. Okay, so now we're going to do lesson 30. a little of the history of complex numbers, and I'm going to skip down to this right here. Actually, we don't really have to do that. Let's go ahead and do it. It's okay. So, looking at this, are there, oh, that's funny. I used the highlighter, sorry. Are there any values of -6 that add to 1? And hopefully you got 3 and -2. So we have x plus 3, x minus 2. Well, in order to graph this, don't I need to know what my vertex is also? Okay, so my vertex is going to be -b, so -1 over 2 times 1, so -1/2. So we know so far that -3 is going to get me 0, -2, -1, 0, 1, 2, and then 2 is going to give me a 0. But the vertex point is actually right here. It's halfway in between 0 and -1. So we have to plug that in. So f of -1/2 equals -1/2 squared plus 1/2 minus 6. Can I make that any bigger? Just a little. Nope. So 1/4. I'm going to make this into 2/4 minus 6. That would be 3/4. Guys, isn't this the same thing as 0.75 minus 6? So that would get me -2.5. Sorry, -5.25. So -5.25. Now if I plugged in 0 for x, f of 0, that would get me 3 times -2. So that would get me -6. So we know this is -6. If I plugged in 1, I would get 4 times -1, so -4. So now I can graph this. So I have -3, 0. I have 2, 0. I have -2, -4. 1, 2, 3, 4. So that means that this is 4. And then I have -1, -6. I think we have a problem, Houston. Got a problem, Houston. That number can't be right. So let's try this. Or I did something else wrong. Okay, so let's see. This is f of -1/2. I'm going to plug it into the other one. So -1/2 plus 3, -1/2 minus 2. So that's going to get me 2.5. And this is going to get me -2.5. Oh, this is 6.25. That's what it is. Okay. Whew, almost messed that up. Okay, so now I can draw this. Okay, awesome. So how many solutions are there? 2 real solutions. What's my discriminant? So my A value, my B value, oh, really, Kim? B value, C value. So my A value is 1, my B value is 1, my C value is 6. So 1 squared minus 4 times 1 times -6. Whew, I knew something was wrong. So 1 plus 24 gets 25. So that fits in with what we're doing. Let's look at this one. Oh, hopefully you notice this is a perfect square trinomial. So we get this is x plus 3 all squared. That is my vertex point. So that was weird. -3, 0. So -4, -2, -1, 0. 0, if I plug that in, it would be 9. Okay, so let's look at this. Okay, so -3, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1, 2, 3. It goes here. And this one would go here. And this is over 2 up 4. 1, 2, 3, 4. Up 4. And voila. Okay. So over here, there's one solution. So my A value was equal to 1. My B value was equal to 6. My C value was 9. So B squared minus 4 times 1 times 9. So 36 minus 36 gets 0. And that goes with what we've been talking about. Now over here, if you notice on this one, it gives me my vertex. So my vertex is 0, 4. So I can plug that in. 1, 2, 3, 4. It's already in vertex form. Now, that's my vertex, 0, 4. So -1, +1. So if I plugged in 1, I would get 5. That goes here. That goes here. 2. 1, 2, 3, 4. Voila. Does it hit the x-intercept? No real solution. So my A value is 1. My B value doesn't exist. My C value is 4. So 0 squared minus 4 times 1 times 4 gets me -16. Okay, and we're going to come down and I want you to do 9 and 10. Okay, so 9, you would have gotten this as a solution. And you could have either one of these as your solution. And then over here is this solution.